Hello everyone. So today I'm going to continue with this spider movement system. So previously the character was not able to move up when there is a curve in the wall outward. Like if the curve is like a ceiling here into this way, the next surface this can detect, but when the surface is like this outward, it was not able to detect. But now in this episode we are going to implement it so it can detect that surface. So now this guy can walk on any surface without any limitations. Okay, so right, let's see how to implement this. And this episode is sponsored by this generous patron. Thank you very much for your support. Right, so here we have one problem in this system. The problem is we can actually move in this wall here. As long as the curve is to inside, we can go from here and to the top of the ceiling and like this, so the character can go in the full circle. But when there is a curve like this, character can't detect that surface. That's because we are doing the traces to identify the flow. Let me explain with the image. Right, in this scenario we do the traces to identify the flow like this. Here we have one hit and here we have another hit, so this is the flow. But when we are in point like this, here, let me also take a screenshot. Here the traces happen same as before. One is like this and another one is like this, and here we don't get any hits. So that's the reason the character can't scale this edge. So what we have to do is we need to find a workaround to consider for scenarios like this, to enable character to move into the ledge, move up the ledge. Okay, so let me open my spider character. Right, so this is our trace flow event, trace flow section. This is where we do our traces. So if we don't get a hit in this initial trace, so what can we do? Yeah, let's go to another branch, go to the first branch, and again here let's do a line trace by channel. Right, now here starting point would be, here we have this end point, but this is too much because we have 1000 in the 1000 units in front of us in the movement direction, so this is a little too much. So what I want to do is, if we fail to get a hit, so these lines would be much longer. Actually could be like this. So I want to get a 90 get a point somewhere like here and do a trace again like this, two traces. If we get a hit here, do another trace like this, then we can identify this surface. So in order to get this point, I'll call it P. In order to get this P point, what can I do is we can use the same part, but here I'll reduce this to like 300, and that will be the starting point, and the end point would be, we can get the moment direction and we can rotate this around axis. So as the axis I will use actor right vector. Get actor right vector. So I think by doing that we can take this angle. And the degree 90. That's not the end. This is just the direction the line trace wants to go. So I'll again multiply this with a value like maybe 500, and we can add it to this vector. That will be the end. So yeah, just to check if this is working as expected, let me test. So at this point we should get it. Right, we get it, but it is over there, and that's like this. I don't think that's good enough. Too far actually. Oh wait, we can actually get the same angle. No, we don't need this part. From here, yeah, we can add these two together and normalize it, so we can have a unit direction vector. Then we can use the result of this plus get actor location. Yeah, actually we can use the same input here. No wait, we don't need to change the existing code. So here we have the direction from this. Let me multiply this with the value like 300 and add to the actor location. So that would be the starting point, and the ending point would be this. In vector is here. No, in vector is this one. Wait, in vector is this one, this direction vector. Right, now let's check. Yeah, okay, now we get it. But that also, I guess, too far. let's make it like 200. This 100, and let's see, so we can get a more closer point. Yeah, that's better. Okay, so now we have the first point, and if we have a valid hit, let me save this one as hit F1. Right, now hit F2. We need hit F2. For that, we can use the same approach. Same as before, do a line trace by channel. I'll set for duration the debug type so that we can inspect, and starting point would be the same. Ending point, actually we don't have to do this calculation here. Instead of rotating it with 90 degrees, we can rotate it with, let's say, 88 degrees or 80 degrees, something very subtle, maybe 85. 80 is, difference is too much, could be too much, right? Now let's multiply it with the same and add to the starting point. So here we have the ending point of the second hit. Let's check that also to see if we get it as we imagine. Yeah, see, we have it. 2 line traces. Okay, now I'll save the same, save this hit result just like before as hit F2. Now this one, hit R, so that means we should get another line, we should do another line cross slightly to the right of the same line trace, slightly to the right, just like the previous line trace. It should be slightly to the right. So actually we can have the same effect using this. If we rotate this one slightly to the right, that means along this around this axis. So it is really hard to explain, but let's try it out and see if it works. So how to do it? We have this axis. Now rotate around axis, let's say just 5 degrees, and as the axis we need to use, oh wait, not this one, this is what we need to rotate, and the axis we need to rotate it around is this one. And yeah, Then same as before, we can multiply it by 200 and add to the starting point. That will be the end point of the line trace. So here, line trace file channel, starting point is same as before, end is here. Now I'm not really sure about this, but let's try and see what we get. Right, we have it. See, 3 line traces, 2 is in front of the character and 1 is slightly to the right. Okay, so there we have our hit R. Only if we have a valid hit, we can register it as hit R. Right, then we can output this section. So everything else now should work in the same way. I don't think I have to do any other changes. Right, let's see. Okay, it can. Alright, but here I am not sure. Oh, it can, but after this point it yeah, it works. Oh, maybe we have some collision here. Yeah, no. Alright, see, great, it is working. Okay, so yeah, that's all. That's what I wanted to try in this episode. Let me put this on, make it bigger, and try climbing that. Okay. Oh wait, here it's not working. Why is that? Let me enable debug type for this first line trace. Maybe we get one here but not the second one. Okay, so then let's connect this part also here. Oh, let's do the same here as well. Maybe not. Why not? Let me enable debug mode for this too, so that we can have an idea what's going on. Oh, right, this is the problem. Our trace length is too far. Okay, so we need to reduce it. Right, so instead of 1000 and wait, we can solve it right here. Disconnect these two and remove one of these pins and multiply this by, let's say, what's the distance we got here? 100, 200. Yeah, let's use 200 here. And let's do the same thing for the other one as well. Normalize and multiply to 100. Right, now it works. See, great. So it can go in all kinds of places now, and it was already able to work on this type of ceilings and walls even before, but let's test if those systems are still working. Let's complete a full cycle. Okay, it is working. One more thing. Let's add a shape like this and try working on it. Yeah, here, see, it still works. Great. Alright. Okay, so I'm gonna stop this episode right here. And as always, project files will be available for the download through Patreon page. Link would be in the description below. And please note that I will not include this robot model because I don't have rights to share it, but I will replace it with something else like a sphere. But you will have access to all the blueprints, all the logic, movement logic that I have implemented here. Okay, thanks for watching, and if you like to support my work, you can get the membership of the Patreon club. And see you in another episode. Goodbye.